We start on page 180 in our books. So we're going to start problem solving with proportions, and these are the slides that go along with your book. So I would suggest that you actually do read the section. It's page 180 through 183 in your book. That'll give you a good idea about what we're going to talk about. So the first thing that we talk about is ratio. And there is a definition of ratio. A ratio expresses a size relationship between two sets and is defined as a quotient. Now, the word quotient has a meaning in math, and it just means to divide. So quotient means to divide. It is written using the word to, a colon, or a fraction. That is, if the ratio of men to women is 5 to 4, this could also be written as 5 with this colon 4 or 5 over 4, and it will be a reduced fraction. It will have two numbers, so even if you get a whole number, you're going to put a 1 underneath it. So here are some examples of writing your ratios in lowest terms. If we were to look at the first one, 4 to 52, we would take 4 over 52, write it as a fraction, and reduce it, and you can take your calculator. Now you guys should have the TI-30XS, so you will take the calculator and you will hit the 4 and then the button that has the N over D, and then type in the 52, and when you hit enter it will reduce it for you to 1 over 13, and that is a reduced ratio. If you were doing this one, you would do 15 over 3, you would reduce it, and it would be a 5 to 1 ratio. Now these that have mixed numbers in them, you have a button on your calculator, you have a green button that says second, and then this button that looks like this. So when you hit second and that button, it actually accesses the mixed number button for you. So if you hit second and that button, it's going to give you the option for a mixed number, and it's just going to appear on your screen like this, so that you can actually put these numbers in your calculator. So you can take 1 2/3, hit divided by 3 3/4, and that will reduce it for you. So play with that a little bit and make sure that you can get an answer of 4 over 9 for that one. So these are some of the things that you're going to be doing in this section. Let's go on. We're looking at these slides actually go over those problems that I just did with you and give. So you could pause this as you go, pause this video as you go, and make sure that you can actually do these problems and that you get an answer as you go. This is the one we just did, and I got 4 to 9, and it could be written as a reduced fraction, or with the 2, or with the colon. So those are various ways that you can write this. So our first definition was for ratio. Our second definition in this section is for proportion. And a proportion is a statement of equality between ratios. In other words, you have more than one ratio. So ratios actually make up proportions. The notation used in some older books is A to B, and then this notation here shows that it is a proportion. You will probably not see that anymore, and you certainly won't see that in this book. You will probably see it look maybe like this, or you might just see it as two fractions with an equal sign between them. That's probably what you're going to see. And these on the outside are called extremes, and the ones on the inside are called means. And when you put them together, this is a ratio, this is another ratio, and when I put them together with the equal sign between them, that is what makes it a proportion. Here's an example of two ratios put together to form a proportion. And you read it, if you notice it says you read it as 2 is to 3, as, that's your equal sign, 10 is to 15. Notice this fraction isn't reduced, this one right here. And the reason it's not reduced is because they're going to be equal to each other. So if we didn't reduce some of them, we would just have 2/3 equals 2/3 equals 2/3. It's just showing you that these are actually the same fractions. That's basically what a proportion is. It's going to be the same fractions written in two different ways. So when we get over here to this one, what it's really asking you to do, it's saying find something that you could put over 5 that would make it equal to 3 over 8. So this is saying m is to 5 as 3 is to 8. And you're trying to find the m that actually works for it. That's what you're trying to do. This one is your basic property of proportions, and I know this is math language, but it says if the product of the means equals the product of the extremes, then the ratio forms a proportion. Basically, if the two fractions are equal, it's a proportion, and there's a really easy way to check it. This property actually says, it says take this number and multiply it by this one, and this number and multiply it by this one. So we're cross-multiplying. And if the two products or the two answers are the same, then it is a proportion. So it says tell whether each pair of ratios forms a proportion. So you just take the two fractions and you take your calculator and you say 3 times 48 and 4 times 36. So if I take my calculator and I punch in 3 times 48, I get 144. And if I punch in 4 times 36, I get 144. So yes, this is a proportion. And that's all it's asking you is it a proportion? If I do this one, 5 times 22 is 110. And 7 times 16 is 112. So these would not make up a proportion. So they're not a proportion. Now you will be using this property in order to work some of your problems that you're going to have. You're going to have things that are like the level 2 drills on page 183. And at the top of page 184, you're going to see things that look like this. 3 over k, and this is actually number 33 on page 184, equals 2 over 5. And the directions say solve each proportion. So you're going to say 3 times 5 is 15. K times 2 is 2k. And you're going to try to get the k by itself to figure out what k would be. And what you're always going to do is you're going to divide by the number that is beside the k. This is your basic algebra that you've had probably for several years. So k in this case is going to be 15 halves or 7 1/2. You can write it either way as long as it's reduced. So those are some of the problems that you're going to be doing in this section.